Hello, everybody. Welcome on the Lights on Data Show. My name is George.
And I'm Diana.
And today we're going to be talking to you about AutoML with the author of this amazing book, Practical Data Science with Python. And his name is Nathan George. We're going to find out a little bit more about him in a little while. But I want to make sure that you know that while you're doing this live session, you can win a copy of this book courtesy of Pact. So all you have
Wow.
to do is, I know. All you have to do is use hashtag Pact in the comments throughout the show, and we're going to have the giveaway at the end of this session. So please stay tuned until the end to see if you're the winner of this. And of course, if you don't get a chance to, you can purchase it too. Right now, there's a deal up until January 18th that you can purchase the ebook version for $5 only. I'll make
Oh
sure
my God.
to post a link in the comments there. It can't get better than this, right? It's practically free. It's a really great deal and it's a really great book. But anyways, back to our session on AutoML and our guest, Nathan George.
Yes, I have the honor of introducing our guest. He is currently a senior data scientist at Tink, a fintech company out of Stockholm, Sweden. He taught data science as a professor for 4 years at Regis University in Denver, Colorado. He has a background in chemical engineering, phosphors of LED lighting, and thin film solar cells, and leveraged what he learned in order to become a data scientist. He studied chemical engineering for both bachelor's and PhD degrees at Colorado School of Mines and UC Santa Barbara, respectively. Part of his journey to becoming a data scientist included the Data Science Immersive at Galvanize in Denver, Colorado. Our guest has created data science courses for Regis, Data Camp, and Manning Life projects. Nate also serves as a mentor for students for Udacity's AI and machine learning nano degrees. Everyone, please welcome Nate George.
Hello.
Hi,
George,
Nate.
Nate, such a pleasure to have you today. Really, your background is amazing, is stunning. It's such an honor to have such wonderful guests to have who can provide us such amazing insights. I have a more personal question for you. I
Okay.
always do at the start. Tell us a fun fact about yourself.
Right. Yeah, so one that I kind of thought would be fun to share was while I was teaching at in Colorado at Regis, I was also
Mhm.
a ski and snowboard instructor for a couple of years, part-time on the
Nice.
weekends. So that was pretty fun because yeah, you kind of get plugged into the culture. And I guess one thing I've learned over the past 6 years or so while teaching a lot is that you learn something a lot better while teaching it.
Yes.
So yeah, that also became true for skiing and snowboarding. So I got a lot better at those while I was doing that, but also made some good friends and had a lot of fun. So that's my fun fact.
I love it.
That's
I love it. And I agree. I agree. When you learn something in order to teach it to others, there's a completely different level of learning that happens there. And ultimately, teaching is actually the same no matter what you teach. Whether you teach data science or you teach yoga like I do, or you teach snowboarding, the principles are the same. And I think it's also very, very rewarding. So thank you for sharing.
and thank you for writing this book, Practical Data Science with Python. As I
Mm,
mentioned before the show, I started reading it, and I think it's chock full of practical information for anybody that wants to learn more Python and they're just getting into data science or they want to get into data science. It's great, and right, you cover a breadth of things: the intro to data science, how to get started with Python, how to deal with data, so data wrangling and a bit of SQL scraping and so forth and so on. Machine learning, of course, data storytelling ethics, and within machine learning, you have a session there on using AutoML, which is the topic of today's conversation. So let's get into that. But first, I do want to mention again to those that are joining us live that you can actually win a copy of Nate's book, Practical Data Science with Python, by using the hashtag Pact in the comments throughout the show, and we'll do a raffle at the end. So AutoML, what is AutoML?
Yeah, so I guess it can be kind of some different things, but the general idea is to automate some of the more tedious parts of the machine learning process. And so some of those things tend to be like trying a bunch of different machine learning models, comparing them, selecting the best one. If you do that from scratch, it's a lot of code. Like in the book, you can see, I don't know, 10 or 15 different machine learning models you could use. So you have to, if you want to do that from by hand, you have to, write a bunch of code to try each model, calculate some score, compare it, and then choose the best one. With AutoML tools, you can just use like a few lines of code and do the same thing way faster. So that's kind of the general idea. Is it's I guess an analogy might be kind of like a few hundred years ago, farming was very manual. You had to like go pick things out of the ground by hand, and now a lot of farming is mechanized. There's even people doing like robotic strawberry picking, which is really complex. So it's kind of like that. It's just like an extension of our tools that makes life easier.
Right.
But geared towards machine learning, of course.
And what would be the benefits of it?
So one thing, like I mentioned, is just kind of an efficiency boost. So it allows you to get to a good, like a decent baseline machine learning model very quickly. So instead of like fiddling around tuning a model and trying different models, you can just get to one that's tuned and the best one out of a selection of models pretty quickly. If you look at some of the tools out there too, so I think one good place to maybe start looking at this is Google Cloud's AutoML services. So they've got video, they've got audio. I think if they don't have audio, other people do, but they also have like text, images, and just kind of like tabular columnar data. So where was I going with this? Yeah. So if you, yeah. So say you have like some sort of image classification you want to do, where kind of a fun one is like take pictures of dogs and classify their breed, like tell you what breed it is. That's a Udacity project. It's actually a project that I tried like, I don't know, 7 years ago with kind of more classic computer vision. And so if you try that from scratch, or even, with some of the more modern machine learning or neural network tools out there, it takes a really long time, and you might not even be successful after spending, who knows, like hours or days working on it. Whereas if you use Google's AutoML solution or others that do similar things, you can do it in a few hours and be guaranteed good results, as long as your data is good. So, but yeah, like I said, it's a big time saver, and it can also allow kind of like sort of non-experts to use it. I want to be careful with like recommending that though, because it's not at the point, I don't think, where it's just you want to use it as like a magic black box. So you don't just want to come in knowing absolutely nothing about machine learning and then try to use it for your problem, because you might end up with some issue that is kind of more, it is problematic, but like stems from a technical issue like overfitting or just kind of various bad data problems. So yeah, it does kind of, I guess, lower the barrier of entry for how much knowledge you need to use it. You don't have to be like a coding expert. There's GUIs you can do it with. But I think you still want to know a little bit of kind of machine learning basics. But that is another benefit, is that you can use it without spending a ton of time learning Python or R or Spark or whatever.
In your book, you're talking about the no free lunch theorem. What is that about?
Yeah, so that's a mathematical theorem, at least for machine learning on that side of things. I think there's a couple different things there that are related to it, but for machine learning, it means that you don't know which model, a priori, like off the bat, you don't know which model will be best. And so you have to try several different models to find out which one's best. And so that's the no free lunch. It's not like you can just use one model and always get the best result. You have to try a bunch.
Right. And then, like you said, using AutoML will really simplify the process, because it takes time for you to manually try every model over and over again.
Right. And it's repetitive. So it's like anything that's repetitive, you want to automate. And that's the idea.
Right. And you're also mentioning in the book that the AutoML idea has been around since the 1990s, but it's really just starting to emerge as widely used in the 2020s. So 30 years later, do you have any idea why it took 30 years for this to happen?
Probably a few things there. One is the amount of data needed. So for most machine learning, you want to have a minimum of, say, like 50 labeled data points, but that's like a very bare minimum that will, depending on your problem, you might need, you might want to have more like 100,000 data points or something, or 1,000,000 or even more. So kind of with computing evolving and data becoming, or data storage becoming cheaper and the internet happening, that has led to this huge explosion of data and data availability. So I think that's part of it, is that there wasn't, machine learning was useful before, I guess 30 years ago, but I think it's way more useful now that we have so much more data and better quality data. I mean, even like looking at images and video, we've got, there's so much image and video data out there. And it's higher resolution than it was 30 years ago. So that's part of it. And then I guess new algorithms have been invented even a couple of years ago. So I talk about some of them in the book. There's light GBM. So that's a gradient boosting kind of like decision tree based method. That was developed by people at Microsoft. I think 2016, I think, was when it was published or released, around there. And then a few years later, I think it was Yandex, a Russian company, published Cat Boost, which is a similar algorithm, gradient boosting. And that's more geared towards categorical data. And so I think you have this explosion of available models over the last 30 years as well. So probably 30 years ago, I don't know, maybe there was like, you maybe had like 10 models to try. And now you could probably try 40 or 50 at least. And then within those models, there's all the hyperparameter tuning so that the size of the problem explodes really quickly, I think.
Not bad. And as new models get developed, do you think these are being added as part of the option, or it takes some time from the time a model is developed up until it gets added as an option here?
It depends on kind of what level of AutoML you're using. So, so you can use like the GUI level, which like Azure, Google Cloud, Amazon. There's a bunch of others. There's ones that are not on the cloud as well. There's like Weka and or Weka, and I think Alteryx probably has something, but that's not free either. But anyway, the point is, some of those easier to use like GUIs are going to be slower to adapt usually and less customizable. But with PyCaret, the one that we cover in the book, that one, even when I was writing the book, I think from the time I started writing the book to when it was published, PyCaret had already added some more models. I mean, so that was less than a year. They had added several more models, I think. So
nice.
And that was just by default. So I think there's probably, once you get to that lower level where it's more customizable, there's usually a way to just add whatever models you want. So they usually make that pretty easy.
So back to the first thing that you mentioned about the GUI option. So that comes as a default package with some of these major cloud providers, or is that something that you need to install it as an extension?
No, for the cloud providers, it runs as like a browser in the browser. It's just like an application you can use in Chrome or Firefox or whatever you use. So there's nothing you really need to install. I guess if you're worrying about like data privacy, then you have to get that kind of sorted. But if you're storing all your data on the same cloud provider that you're doing your AutoML with, you can probably figure that out pretty easy. But for other tools, it's possible to install them locally, and then they pretty much run on any major operating system. But I think probably the easiest to get started is to try one of the cloud provider tools, because it's literally sign up with an account, go through one of their demos, and then kind of see it in action.
Right. And with the do-it-yourself installation version that you mentioned, then is that do you need to install it as part of your one of your Python libraries?
So there are some where that you can install them just as like a standalone executable.
Mm-hmm.
Like yeah, so like Weka or Orange is one that actually uses Python, but it's a GUI. Or Alteryx or RapidMiner, any of these kind of like data science GUIs.
Mm-hmm.
Yeah, you can use them for that. But if you want to get into like Python packages, then that's getting a little bit more custom. You've got to understand how to install those and deal with like a Python environment. So I guess those are maybe kind of like 3 tiers you can think about. Would be the cloud providers being the easiest and quickest to start, and then installing some local application being the next easiest, but a little more work, and then kind of using code with Python or R or something else being the hardest.
Nice. Thank you. I
Yep.
want to start taking just a couple of questions from the audience here. Thank you, everybody, for joining us live. First question I'm going to take is from Ravit of the Ravit Show. Welcome, Ravit. Thanks so much for being on part of the audience here. He's wondering, how will AutoML change things in the next 2 to 3 years in the field of machine learning?
Yeah, so I think it's similar to any other kind of productivity tool, I guess.
Mm-hmm.
So you're going to be able to do more as a single person, as like a data scientist or machine learning engineer. I don't think it's at the point where it's going to be replacing jobs. That I think is still, I don't know how long off, or things evolve, so always be a need for people to be in the loop at some point, I think, at least for a while. But yeah, so I think it'll probably lead to just, I guess, better machine learning applications out there, so more people can take their idea and make it a reality. So that'll be really nice. Yeah, and I guess it's a new skill to learn as well. So if you're in the field of data science and machine learning, you should definitely be learning it and using it when you can, because it's a real efficiency booster.
Nice. And I have a question here, which maybe I think I know the answer to. Ismail is wondering, which programming language does Nate recommend for beginners to learn machine language?
Definitely COBOL. Just kidding. not COBOL. Python. I think Python is good for now, and it has been for a while. So Python, it's like made to be easy to read and understand, and it has a really large community. So it has these big network effects. If you need help, there's a ton of people out there willing to help you. There's a lot of information on it. There's a lot of people developing packages for it. So I think that's, and then another thing is there's a lot of tutorials for machine learning in Python. So, I've got the book, there's other books, there's a ton of blog posts. There's just so much information out there that I think Python is really the best. I guess another one that is good and some people really like it is R. It's kind of like the other data science language besides Python. And it seems like whichever one you start with, you end up liking a lot more for a while, maybe forever. So some people get really, they take a really strong side on which one they like. So I recommend against that, but I understand why.
And Nate, you're covering quite a few machine learning topics here. You're talking about machine learning with regression and classification models and optimizing models, a few other things in your book. So back to Ismail's question, this is definitely a great resource to start learning machine learning with.
Yep.
All right. Well, I'm going to take a few more questions here. This one comes from Johan, and he's wondering, where do you see the most value of the AutoML practical finding patterns of tumors in images or X-ray?
I don't know if I fully understand the question, but so it seems like trying to compare between two applications of finding like tumors, maybe brain. I've seen brain tumors in images that have been detected with ML. That was with MRI scans, I think. So I don't really know what you mean with images, because X-rays are images actually. That's how you process them. But yeah, I think you can use AutoML for that. I think that's not a problem. If you look at, for example, Kaggle competitions, or depending on the specific application you're looking for, you can go see some competitions for it, like detecting COVID in the lungs from X-rays. I think there was a competition for that. So you can kind of see like what the state of the art is and what people have used for that. But AutoML for images, I think, should work fine for that. The harder part, the AutoML part, is not that hard, I don't think, anymore. It's actually relatively easy. You get your data, you chuck it in, you tell it to predict something, and it predicts that thing. But I think the harder part is getting the data. So if you're trying to do like a medical application like that, where you want to detect tumors or COVID or something, or like pneumonia, you need a lot of data usually, and the data needs to be good quality. So and it needs to be labeled. That's the other really hard part, is you need to have, if you're trying to like detect a box in an image where a tumor is, all those images need to be labeled, and you probably want to have like 100,000 images. So that takes a long time. You need a person doing it by hand. So I think that's the part that is pretty tough right now, I think, for ML.
So what part does the person need to do by hand? Is it the initial identification of the tumor on those images, just to give the program some inputs on, hey, this is what a tumor looks like?
Yes. So kind of the way it's been done usually is you can either have it like, you can just draw a box around it. That's like a super simple way. And then just give it the coordinates of the box, and then have it predict those coordinates from the image. Or you can kind of like use like a painting tool and kind of like paint a region, and then have it predict those pixels that you painted. And that's a lot more complicated. But either one works. But you need some sort of labeling tool. There's an open source one called Label Studio. And I didn't really look into it, but I think if the cloud providers don't have, the major cloud providers, if they don't have a labeling tool yet, I would assume they'll have one pretty soon. But yeah, that's, I think in terms of, those medical applications, that's not a blocker, but a really hard part of the problem.
Interesting. Christine
Thank
here
you. Yeah, go ahead.
Just want to take this comment from Christine, that she's mentioning that genetic research has used machine learning to seek out associations between gene combinations to particular diseases.
Yeah. Wait, can you put that one back up again, or is that
Yeah.
possible? Just so I can read it again. Right. So yes. So that, I guess, I'm not sure if that's using unsupervised learning or not. So I'll have to look more into that one, but that definitely sounds like an interesting application for sure. But yeah, if it's using unsupervised learning, you'd kind of like cluster gene combinations, and then maybe see if those clusters of people that are like the people that fall in those clusters, if they tend to have a disease or not. Then you can kind of like tease out the statistics and see, is that gene combination related to that disease?
Nice.
Yeah.
And then I cut you off.
I wanted to ask Nate, so besides these medical applications that have the potential to be groundbreaking and have been, what other applications does AutoML have that can really affect our lives?
Let's see. So I guess there's a lot of natural language things you can do. So you can, like some of the applications of it are like chatbots or question answering. That's a lot more complicated and on the NLP side of things, but I think that will be pretty useful in the future. Probably kind of giving a vague direction, something around augmented reality. So again, image processing. That's, I think, kind of maybe the limiting factor there is kind of figuring out how best to use image processing with augmented reality, which I don't really know. But you can do things like segmentation of images. So you can take a picture and have it draw bounding boxes around different things. I think that will be, could be something that would be interesting or important in the future. I think with some of the, like one really trendy thing, I guess, is self-driving, like self-driving cars. I think that is not something that AutoML is going to help with. It's kind of, yeah, it doesn't make sense to use AutoML for, because it's, I guess it's like one specific thing. So you kind of like you build a purpose-driven system for that, and it's super complex. I think when you can like boil down the problem to be a little simpler, then it's better. But probably some image classification applications will be important. I think perhaps with like food, so or even just manufacturing, like quality control, image-based quality control, like automation. I think it could be useful for that. Let's see.
That's a lot of applications.
Yeah,
It's quite a few. I think there's even more though. I think medical too is a big one, of course.
Yes.
I have another question here from Bharat, and he's wondering how much pre-processing is required in AutoML versus traditional machine learning algorithms. That's
a good question, Bharat. So we didn't really get into it in the beginning either. So AutoML is kind of, it's kind of broad, as you maybe guessed, but we didn't really get into it. So there's some AutoML applications or programs that will actually take you from raw data all the way to a machine learning model. And they'll also try a bunch of combinations of pre-processing. So some, let's see, what's the one? I forgot the name of the package that does that. It's on the tip of my brain, but I can't think of it. But one of the packages that's available in Python, it will try some different pre-processing. Even PyCaret does that. It tries a bunch. You can have it try different pre-processing steps. But it's still kind of limited because these are kind of early days, I think, still for AutoML, even though it's been around for a while, I guess, the idea. So when you're doing ML more by hand, or even with AutoML, I think you do need to think carefully about your pre-processing, and maybe have a little bit of domain knowledge about it. So like in text data, for example, if you're going to make a question answering bot, you might want to do some cleaning of the text before you pass it to the AutoML algorithm. Or if you're working with images, again, like data cleaning, super important. I think I mentioned in the book that people spend something like 2/3 of their time on data cleaning often, or more. So it's, AutoML can take care of some of that, but I think your pre-processing still has to be somewhat manual these days, unfortunately.
Nice.
Hard to get away from the data janitor work.
And if you don't mind telling us again, really, what is AutoML in a couple of sentences? Kieran was wondering as well, and there are a couple of other people that joined a little bit later. And I have to be honest with you. When I first read AutoML, I was thinking, well, isn't machine learning already automated? Isn't that sort of the point of it? Why is it auto? So what is that difference?
Yes. So a machine learning algorithm by itself is like automated pattern finding, right? So give it some data, it's going to pull out the patterns for you. So a good example is our transaction classification app at Tink. So we take in a transaction description at a kind of at like a basic level. You can think about it as matching keywords to categories, and it's finding those patterns over billions of transactions. You don't want to do that by hand. So that's the automation of the machine learning, right? Mm-hmm. AutoML, on the other hand, is trying a bunch of machine learning models, comparing them, finding the best one and just giving you that result, so you don't have to do that by hand. And then so that's kind of like a base level AutoML application. But depending on which one you're using, it might also allow you to automate searching hyperparameters, which is optimizing the algorithm to perform better. Or it can also optimize the pre-processing steps of the data. And then it usually has like a lot of periphery functions as well. So it can automate some analysis and stuff like that. So, but the core of it is basically trying a bunch of different machine learning models and giving you the best one.
Nice. Thank you. There's some comments and discussion going there on which programming language is better, and Ravid is mentioning Python all the way for sure. Hish is actually saying that they're still using COBOL. So I'm wondering, Hish, what industry and company you're working for? That would be cool to know. We have a question here from Dev Gaba, and he's wondering, he's new in data science field and just completed his master's at the same time. Any tips for him to grow into this field, into data science?
Sure. One thing you can do is find some projects to work on. So it could be like Kaggle or some other data set you're interested in. If it's not Kaggle, you kind of have to come up with your own question, which is always really good as well. But you might have to gather your own data, which is more work. So I'll leave that to you. But once you go through the problem, publish a blog post, and that way you can, so when you like write down what you learned and teach others, it really helps you crystallize those thoughts in your own head. And then you're also kind of making a portfolio piece for yourself. So that will kind of be like an advertisement for yourself. So if you're job hunting, it helps. And then it'll help you get in touch with the community in general. If you post on like Medium, for example, they have discussions where you can talk with people in there. They can ask you questions or leave feedback. So that's one thing I would recommend. And obviously like reading other people's work and maybe commenting on it. Kaggle, I feel like it's pretty good to at least check out and kind of be active in if you can, but it's a bit of a mixed bag. So, but yeah, if you have time to maybe work on a project and publish it as a blog, I think that's a really good move.
So putting your work out there and showcasing your,
Exactly.
We have another question here from Ari Hunt, and he's wondering, how is feature engineering handled by AutoML? Because feature engineering is completely data dependent.
Yes. So there are some AutoML packages that try to do some feature engineering, kind of basic stuff. But I think, that's still a place where domain knowledge is kind of important. So it does help to know what you're doing and have some experience there, or have a human in the loop to try some things that maybe aren't coded in the AutoML algorithm, or just something that is known to work for that sort of data.
Nice. Oh, and we have Kate Strachny here of Datacated and the Datacated Circle, and she's mentioning that Kaggle is great, and she agrees that a project portfolio showcase is very smart. So please follow Nate's advice and start your project as soon as possible. All right. Yes, Deanna.
I am very curious, Nate. You are a teacher. You came in contact with many students, probably of different backgrounds. I'm not sure if of different ages as well. But did you see a pattern? Did you see any pattern in your students' interests or inclinations or anything? I'm just very, very curious who is now studying these subjects and what are their ideas, what are they up to, and so on.
I guess my sample size is very small and biased because Regis is a smaller university in Denver. Most of the students, like 80-90% of our students, were from Denver. So it was, we did have some students, like international students and things, but yeah, I think that sample size is kind of small. So I guess probably I'm trying to think of a better data set for that because it'd be better to get like a more all-encompassing data source to study that question. I think it's an
Right.
interesting question, but yeah, I guess one thing I noticed is that I think most people that were doing it already were kind of in tech or peripheral to tech somehow. Some people come in and do a career change, I guess, from something completely unrelated, like music. I actually
Hmm.
went to the Galvanize Immersive with someone who was a music master's and had I don't think he had ever done a math class in a university.
Hmm.
So that was interesting, and he
Hmm.
succeeded, I thought, really well in the program, but ended up not being a data scientist. He didn't like it, I don't think. So yeah, you've got to like computers, you've got to like math, and I guess you also need to like communicating with other people, though, because that's a part of it. But yeah, I hate to say you want to be a little nerdy, but you probably want to be a little nerdy to be in it, I guess, or at
It's
least
great.
accept it.
You do. It's great. Um, and that being said, you also being an instructor and or you're a teacher, how do you keep up to date with everything that happens in data science?
So that is super difficult. I think this is in part, I think that the size of the book is an illustration of why that's
Yes.
difficult. Is just data science is super broad and it keeps expanding. It's like, I don't know, it's like the blob, or I can't think of another good metaphor for it. But so staying up to date with it is equally hard as trying to cover the entire subject, because what do you consider data science? Do you consider like neural networks data science? And if so, that is its own can of worms. But some ways are like some different newsletters. So I talk about some of them in the book. Honestly, I haven't had a ton of time to do this myself. So
Hmm.
yeah, I don't know if I'm the best example. Um, but like Andrew Ng has a newsletter through, and I didn't prepare, so I forgot the name, but his AI company or organization. And there's others. And then Kaggle also, I think, is, so it's kind of a nice way to stay up to date. It's actually how
Mhm.
like a few years ago, I was browsing through, they make it like a Facebook or Twitter stream, basically like a social media platform, probably to make it addictive, I guess. I don't know. But I was browsing through it, and that's when I first discovered Light GBM a few years ago. And it was pretty new at the time. So I think, yeah, just browsing around on Kaggle is kind of an easy way, because it's low energy, I guess, to just kind of look at what other people are doing, and then you'll inevitably run into the cutting edge there.
Hmm.
So that's kind of a good way. I guess if you're into other social media sites like Twitter or Reddit, there's probably a lot of good stuff there too. I guess that has the danger of getting unfocused and like shifting to another topic besides data science. So Kaggle is more focused. And then a ton of blogs. So Towards Data Science, I would say, is probably one of the top data science blogs out there.
Mhm.
So like whenever I Google something, almost always a TDS article comes up near the top 2 or 3 results. So, I mean, probably if you were just to read some of their recent articles, that'd be good too. I come across enough just through like work and other stuff I'm doing that I don't even need to go and like see what they're releasing recently, because I already read too much of it. But that's probably another way.
Hmm. Great, great suggestions. Thank you.
And as Kieran mentioning, data science is an
Yeah.
ever expanding universe as he sees it. And
Yeah.
Yes.
Dr. Shailesh has a recommendation here that he can write a book to keep yourself updated.
That's one way.
So yeah, everybody you can start doing that. And I know we had a question here earlier that I'm
Um,
trying to look it up really quickly. Yes, Diana.
I just wanted to remind everyone about the raffle. If you can show us again the hashtag. Yes, so everyone, please mention the hashtag and you will be included in a raffle for Nate George's book. at
There
the
you go.
end of the show. Yes.
Yes. Okay, I found the question that was related to the previous one, and Kate was wondering, how long did it take you to write the book?
Mm-hmm.
It took about a year. I actually tracked it after the first month or so. So actually, Shaylesh, who just posted a comment, was I think the person who first contacted me about it. So glad you're here, Shaylesh. But that was around. I could pull up I have it in a spreadsheet. So around like August or something like that, a couple of years ago, and yeah, and then I tracked it and finished it kind of basically July of this year. So it took about a year. And I think the average time per week, I posted the stats on LinkedIn. I think it was like only 10 hours a week on average, but there were definitely some weeks where it was a lot more than 10 hours. So I think near the end, it kind of tailed off, but in the middle there, it was probably more like, I don't know, 15, 20 hours a week for some weeks. So
Well,
it's,
I know from my own experience that 10 hours of actually creating valuable stuff for a book is a lot.
Mhm.
I wasn't able to do more than 2 to 3 hours of actual productive work on the book that I was writing. After that, I find that it's very, very hard to really create valuable things. So 20 or 15 to 20 hours is amazing also besides a full-time job. So congratulations, Nate. I think that's a huge, huge achievement.
Yeah.
And it's also a very nice legacy to leave behind and to say, okay, I wrote a book. I know that people usually are impressed when when I say that I have written a book. So I think you get the same reaction.
Okay. So I think we have time for a couple more questions here. And let me quickly just bring up this one from Mike Nash. Hi, Mike. So he's wondering, for enterprises, is there an economic benefit to go the AutoML route? Will this become the standard in the future?
good question, Mike. Yes, I think there is an economic benefit. Even if you're not using AutoML, there's also ML ops, machine learning ops, which is kind of a big thing now. And there's a lot of startups out there. So those are they usually incorporate AutoML as part of their pipeline, but they also kind of have tools for doing everything else. I don't remember the name of the company that we're actually going to be trying out at Tink soon. I don't know what the best way is to share that, but yeah, I think ML ops companies might be even better than AutoML, and they kind of take away a lot of the like drudgery and a lot of the time consuming parts that aren't really high value add. So like an example with using AutoML for, like, say you're a bank and you want to offer, or like a banking app or like something like that, and you want to offer customers small kind of micro loans. If you want to, and you want to like evaluate their credit risk, you can go from some data that you have on existing loans you've given out and who is defaulted and who is not. You can go from that data to an AutoML app that's like live, served as an API in a few hours on Azure, for example, is one thing I've seen. So whereas if you do it from scratch and build all the DevOps stuff yourself, it's going to take days or weeks, maybe, I don't know, depending on your experience. Maybe a day if you're like really good at it, but then that'd be probably expensive to pay that person. So I think, yes, there's a huge economic benefit, and I think it'll become part of the standard in the future. But like I said, I think the ML ops paradigm will probably be more of the way to go, because that incorporates like data pipelines, data science work, analytics, model monitoring, deployment. It has kind of everything. So I think AutoML is like one piece of that puzzle. But
Nice.
yeah.
Nice. And Raj is mentioning that AutoML to him is a must. He encourages his team to use it, and he wants his team to focus on the problem and delivering closest probable solution. And also that AutoML does the heavy lifting and helps remove a lot of fuzz. Sounds good. And Dev was wondering here, I don't know what the acronym stands for. Maybe it means something to you, Nate, but is EDA part also automated in AutoML?
Yes, EDA, exploratory data analysis. That is not usually automated in AutoML, but it's good that you bring this up. There are a lot of AutoEDA packages out there. I was looking for some GUIs. I don't know if it's as prevalent in GUIs as AutoML is, but definitely in Python, there's, I don't know, about 5 or 6 AutoEDA packages. Pandas profiling is the one that we talk about in the book.
Mm-hmm.
So those also save a lot of time because you can chuck in some data and have it just spit out a ton of graphs and statistics. And so it saves a lot of time. But it's usually not a part of AutoML.
All right.
But you should definitely do it. It's essential. 100%.
And Arihant was wondering if you have any suggestions on how to decide which AutoML tool to use for a project.
Sure. So I guess you first have to kind of figure out what skill level either you're at or whoever is going to be doing it is at. So if you have the skill to maybe do it in Python, then you could use that, for example. I guess kind of the trade-off between using a GUI, like the high-level GUI, and the low-level programming solution is that the GUI is usually the fastest and easiest way to do it. But it's usually less customizable. That tends to always be the trade-off, is that fast and easy, less custom. When you go to the lower level programming custom solution, you can usually like customize anything you want. You can squeeze that last bit of performance out of it if you want, but it's going to usually take longer to implement. So that's kind of one trade-off to consider there. Like, how much time do you have? How much of the tippy top performance do you need to hit? And then kind of what skill level you're at. And then that can help you, I think, decide which one to use.
Right.
But then I guess within the GUI tools and within the programming tools, in the programming tools, like I said, some can automate the feature engineering and data preprocessing. So you have to decide if you want to incorporate that or not. Some of them have different models available, so you have to think about that. Same idea for the other side of things, like depending on which application you want to use, you have to think about that. And then you got to weigh the costs between all the different like cloud providers if you're going to go that route. So there's quite a few things to consider.
Awesome. And how well does AutoML scale with data? Raj was wondering.
This depends on which AutoML you're using. So it doesn't really depend on the concept of AutoML. It depends on, like, are you using Python on a single like laptop? Then you're going to be limited by the components of that laptop. So if you've got 16 gigs of RAM, you're not really going to be able to work on more than 16 gigs of data very easily. Whereas if you're on the cloud, more or less, you're kind of unrestricted to like almost infinite sizes. I think so. Like, yeah, you can scale up with clusters. I think H2O, for example, is a package that can scale up with clusters. I think even PyCaret allows you to interface with the cloud and use clusters. So, I mean, if you're using a cluster of computers and you need more compute power, you just add another cluster. So you don't really have a limit, and it scales more like if you look at like Spark, like big data tools, big data machine learning tools, it's going to scale with those tools that are getting used on the sort of more base level.
Nice. Thank you. All right, I think it's time to get there and do the raffle really soon. And I do want to mention that Jay said you got the book. It's solid. Definitely recommended. So Thank you, Jay.
Hey, Jay. He was one of my students from Regis.
Awesome. Awesome. Yeah, so I do encourage everybody to check out this book, Practical Data Science with Python, written by Nathan George, published by Pact. And I posted a link in the comments as well where you can go and get your own copy. But right now, let's do the raffle. Let's bring it up here and see who the winner is. And I might have accidentally entered the raffle as well when I put a comment in. But if by accident I win it, we'll run it again. All right. Wow, Ravid!
Ravid, oh wow!
You won it.
Woohoo! Congratulations.
Took a photo of this. That's
Amazing.
awesome. Good job. All right. So, any lasting words? Any recommendations for those that want to start into the data science field, that are just beginning to the data science field?
Sure. I guess, yeah, you can even start with GUIs. So you don't even have to start with programming if that kind of scares you. The people who haven't programmed before, it tends to be intimidating. So yeah, you can even start with GUIs, and that's pretty fun. And then once you're kind of more interested, you can try the programming if you want to. And then when you do, or if you do get into the programming, I would say try to be patient and realize that it can be frustrating at times. So yeah, just realize that going into it. And I guess, I don't know, use whatever kind of stress relieving strategies you have, like meditation or whatever. But but eventually, I don't know, after a while, you learn to cope with it, and it doesn't bother you anymore. When something doesn't work as it does, you just kind of like methodically work through it. So, and that's a good place to be once you finally get there. But it takes patience. So don't expect it to happen overnight.
Awesome. Well, please thumbs up, applause, for Nate George here. Thank you so much for being with us and sharing your knowledge on AutoML. I've learned a lot during the session, and I'm happy that there's a recording so I can revisit it too. Again, I want to encourage everybody to get their own copy of the Practical Data Science with Python. You can do so at the link here. I'll also post it in the comments. And the ebook version is $5 until January 18th. And I feel like I need to whisper this because it's such a great deal. I'm afraid it's not true. Yeah. All right. Well, thank you, everybody.
And I would also like to encourage everyone to follow Nate and to get in contact with him. He's a wealth of information, as we've seen. His book is also very thick, full of information as well. And thank you, as always, for joining us. Thank you for your amazing questions today. And have a great, great weekend, everyone.
Thank you, everybody.
Thanks.
Bye.
Have a great
Bye.
weekend.